Good morning, good afternoon, good evening to all of you. Thank you so much for joining us today. I'm really thrilled to be here with Gavin and Asher hosting MII's first webinar. I am Nicole Rawling, the CEO and co-founder of the Material Innovation Initiative, a nonprofit supporting the development of next-gen materials, which are animal-free and more sustainable. So before we get started, I want to go over a few housekeeping items. So we actually have over 300 registrants for this webinar from all over the world. This really is a truly global movement. And so I thought to help connect people, it'd be fun if you could post where you're from in the chat, and then we can start to get to know each other and see where people are from. We do have a lot of time today for audience Q&A at the end of the discussion. So please feel free to post your questions for Gavin and Asher in the Q&A section on the right side of your screen, and I'll make sure to ask as many of them as I can. And then after the discussion, so we have that for the first hour, but at the end, the last 30 minutes, we have a speed networking time. And this is the opportunity for us to connect with fellow registrants and of course the panelists to discuss what you've heard today. And hopefully we'll make some new connections. And I'd also like to thank Forager again, because they're our headline partner at our Material Innovation Conference that's taking place in May. If you haven't signed up already, we'd love to see you there. It'll be more of the exciting innovations in the industry that we're going to hear this morning. So now to the programming. I think it's safe to say that most of us are here this morning because we want to learn more about innovative materials. As materials make up around 3/4 of a brand's environmental impact, focusing on developing more sustainable alternatives to harmful materials is a great way to help make fashion more sustainable. This is where I hope MII, where I work, can help. So we focus on identifying white space opportunities in the market where there needs to be more scientific R&D and new companies. And then we work on encouraging more scientists, entrepreneurs, and investors to enter the industry and give them the help they need to succeed. We also advise investors and brands about opportunities in this market. There are huge opportunities for win-wins in next-gen materials, and we believe that smart innovation can solve the industry's problems with raw material development. What Gavin and his team at Forager are doing is a great example, which is why I'm really excited to hear from them this morning. Their new foams and hides are extremely promising, with significantly lower environmental footprints than the incumbent foams and animal-based hides. Material companies like Forager also need brand partners who believe in their products and will help them get to market. Forager's partnership with Vivobarefoot is a great example of a material company and a brand working together on advancing sustainable materials. We expect to see more and more of these partnerships as the industry progresses. In January, we actually published our first brand engagement report, which highlights over 110 products made with next-gen materials. And we'll put that chat for that report link in the chat. So if you haven't seen it already, I recommend you look at that. And then actually just yesterday, MII published our second State of the Industry report, which covers the growth of the industry in 2021. And I'm excited to share, although not surprised, that investment in next-gen materials doubled from 2020 to 2021. In 2021, $980 million was raised across 187 investors and 95 companies for next-gen materials, which is double the $426 million raised in 2020. Because of the work of companies like Forager and Vivobarefoot, creating and using next-gen materials, we expect next-gen materials will grow at an 80% compounded annual growth rate to reach $2.2 billion in 2026. That's actually 3% share of the addressable market. And if you compare that to animal-based materials, that's only growing about 2% compounded annual growth rate. So we see the growth in this industry as really impressive. And because people like you are interested in these more sustainable materials, that's why it's happening. So we'll also put the chat link to that State of the Industry report. So I just personally want to thank both Gavin and Asher for what they're doing to advance this industry. And Gavin, let me pass it over to you to introduce yourself and talk about these new materials.
Hey, wonderful. Thank you so much, Nicole. And thank you all for joining wherever you may be in the world today from your digital devices. I'm going to go ahead and share my screen to talk through some slides to get us started. And so as Nicole mentioned, I'm Gavin McIntyre. I'm one of the co-founders and I serve as the Chief Commercial Officer at Ecovative, the Mycelium technology company. And I'm today also leading Forager, a research division that's dedicated to creating earth-friendly foams and other soft goods for the fashion industry. Ecovative was founded. Screen share is off. Oh, my apologies. Let me do this again. Sorry, I'm told my screen share is off. And we're back on there. Okay, great. So as I was mentioning, Ecovative was founded in 2007. And since that time, we've advanced mycelium technologies towards market readiness and commercial scale. Ecovative and our partners today produce products on 3 continents, displacing tons of single-use plastics every single week. And I'm super excited to be joined today by Asher Clark, who is the co-founder and design director at Vivobarefoot, an industry leader in regenerative footwear and one of the amazing partners in Ecovative's Fashion for Good cooperative. We'll be discussing today the future of mycelium materials and how our Fashion for Good cooperative is realizing that future by connecting leading brands like Vivo with Ecovative's material scientists and engineers. We truly believe that the market is eager for next generation of biomaterials and for the solutions to urgent ecological problems posed by plastics. Together, we're working towards those solutions. By replacing plastics and reconnecting manufacturing with the cycles of nature, mycelium could help transform entire sectors of the industry from product design for the better. And we think that's real cause for hope. Because in 2011, Ecovative developed our very first generation mycelium hides and elastomeric foams with the support of the United States Environmental Protection Agency. Now, mycelium is taking its place among an emerging class of biomaterials that are moving fashion into true circularity. At Forager, that includes high-performance foams for applications in footwear, apparel, and accessories. Biomaterials in general are growing more competitive in terms of price and performance, with scale and commercial availability being the biggest challenges today. Those problems have solutions, though, and Ecovative plans to grow market-ready Forager materials at scale next year. Over the last decade and a half, we've really seen increasing awareness of the environmental consequences of mass consumption, and with it, demand for more sustainable products. For brands, biomaterials offer new and exciting opportunities to meet that demand. At Ecovative, our mycelium technologies are designed directly to integrate with existing supply chains, making it easy for our partners who want to work with Forager foams and hides. So why has it taken so long for biomaterials to become widely available? We believe it's because partnerships needed to move these materials into the market are just starting to form. And in our view, the best and fastest approach is for companies like Ecovative to be working with innovative brands like Vivobarefoot to work directly together. So what does this kind of partnership look like? Well, today we send experimental materials to our partners regularly. Their feedback on performance informs the next iteration of the material, which we send to them, and the cycle repeats. By employing what we call our Mycelium Foundry, which is a suite of research tools developed by Ecovative for rapidly developing and scaling mycelium materials, improvements can be realized quickly. This real-time collaboration makes it easy and possible to share improvements with product designers as they happen, accelerating the development of mycelium materials that meet the high performance requirements of fashion brands. Well, if you've made it this far without Googling what mycelium is, I'll give you a really quick crash course. So first and foremost, mycelium is the fibrous vegetative structure of mycelium, often described as mushroom roots. And here is an example of the Forager foam. In nature, mycelium takes the form of an underground network of thread-like cells that weave themselves together. In the forest, they perform many crucial roles, from binding the forest floor together, literally holding it together, to recycling the leaves and logs and other organic debris to power the next cycle of life. Mycelium is inherently circular by nature, and it's long past time humanity has learned from their example, growing consumer goods that renew the planet that produced them. For the forager division, a hide or foam can be grown really to any size or performance specifications with very little scrap rate. We do this by employing our air mycelium platform in vertical farms like the facility in which I sit today. Today, we grow sheets of pure mycelium that are over 5 feet in width and over 35 feet in total length, and we're currently scaling that to be even larger. Any scraps that are produced are entirely home compostable. And so to illustrate the circularity of forager foams and hides, we truly grow on what are known as plant stocks and seed hulls. These are agricultural byproducts, and our solid state fermentation processes do not consume any valuable food grade resources, such as the sugars that are often used in liquid fermentation. We really do not want to be competing with the food supply chain for humans. With all of our mycelium materials, circularity applies from the start of life to the end of life. We turn agricultural outputs into manufacturing inputs, with the primary leftovers being compost, water, and a very small amount of carbon dioxide as the fungus naturally respires. When we dispose of these materials, the forager foams and hides naturally convert back into soil nutrients. No chemicals or industrial processes are required to properly dispose of these materials at the end of life. So at Ecovative, we truly focus on material properties of mycelium. Forager foams and hides are naturally resilient, water resistant, and offer great thermal insulation. They are durable and tough, able to withstand daily use, but also breathable and soft, with a wide range of possibilities in terms of textures and finishes. The Forager Research Division applies these, among many other amazing attributes of mycelium, to the soft goods category. Mycelium foams are a new and especially exciting category of materials because for the last few years, the community has heard about the development of mycelium leathers. But for the Forager division, we focused on expanding opportunities into high-performance foams that are completely plastic-free. And we truly believe this could be a game changer for the fashion and broader soft good industries. The reason being is that elastomeric foams are literally everywhere. They're in the soles of our shoes and the cushioning of our car seats, and of course, to the support materials found in handbags. Foams are the hidden foundation of much of what we wear and use today. Unfortunately, they almost are always universally made from different types of plastic, adding to the massive flows of non-biodegradable waste streams. And while some have been developed from organic sources, these are usually mixed with petrol-based foams, making them difficult to recycle or reclaim and really impossible to compost. Fortunately, as you can see from this slide, forager foams have already had the ability to meet some of the performance requirements that are required by these applications. And of course, forager foams are completely natural and home compostable, so the potential reduction in plastics is 100%. The fossil fuels used in plastics have taken millions of years to develop and will never fully degrade. But by contrast, mycelium grows and can return back to the earth in less than a year. Rather than pollution at the end of their life, they become nutrition for the environment. So what new product possibilities arise from such a material? That's exactly what we're going to be exploring today with brand partners like Vivobarefoot to draw out mycelium's full potential for the fashion industry. We know mycelium, and we understand that no one knows their markets or products better than our brand partners. And that's why collaboration is core to our innovation strategy. For us, collaborations like the one with Vivobarefoot have been a decade in the making. In fact, our Air Mycelium platform was actually launched specifically with footwear foams in mind. But as a company that started with the intentions of displacing plastics, we're really excited to explore this use case with Vivobarefoot and other brand partners, as it directly aligns with our mission, and we think it stands to make a real and positive impact on the world. I'd now like to invite Nicole and Asher to join me to discuss how brands and material science can change the way we do things today. Thank you, and I'm really looking forward to this conversation.
Thank you so much, Gavin. I loved that video. I hadn't seen that before. where you go into the mycelium under the mushrooms. I thought that was a really good explanation.
Oh, thanks. Yeah, it's a really fun one. And it's really important to understand how our materials are truly derived from nature and how we're taking a natural process and really instituting it into an industrial scale. And so hopefully that helps illustrate that.
Actually, can I ask you, are the products behind you on the shelf, are those all mycelium based?
Of course, yeah. We've got a good range of materials here, from, of course, additional elastomeric foams to leather-like textiles. And of course, our longest standing product is a protective packaging solution that is an entirely home compostable alternative for the plastic foams used to protect goods in transit.
Wow, oh, thank you. Well, I'd love to pass it over to Asher to hear a little bit more about Vivobarefoot and why you've gotten involved with Forager.
Yeah, so thanks, Gavin, and thanks, Nicole. Hello, everyone. My name's Asher Clark. Husband, dad of two, footwear designer, cobbler for my sins. Design director at Vivobarefoot, as Gavin kind of introduced me, and now Vivobarefoot lead. So I get the privilege of spending a little bit more time looking into the future, which brings me here today. And yeah, like swimming and running, we call it swim run. If you haven't tried it, you should give it a go. And I like to surf too. So word on the street is Gavin's might grow me a Mycelium surfboard for Christmas if I'm nice to him. So hopefully that comes about. And so look, our partnership with Ecovative is super exciting. There's a problem afoot, which Gavin kind of touched on, 20 billion pairs of shoes produced each year. I'm guessing a lot of people in the room, in the virtual room, are part of the problem, like us, relying on petrochemical based materials, EVAs, PVCs, chemical rubbers, which is literally millions of pounds of waste destined for landfill and taking centuries to decompose and, ultimately making soil pretty toxic. It's a big problem, and it's down to the shoe industry at large for us to try and solve this, which we're going to talk about today. But material solutions or sustainable material solutions usually have big trade-offs. So it's like performance, cost, scalability, etc. And one of the exciting things about this partnership is that based on the ability to kind of scale and value engineer some of this stuff, it really looks like we've got a scalable solution. And of course, this mycelium or this nature-based thing really fits squarely in the Vivobarefoot mission to reconnect people into the natural world. And what better way to do this than with nature-based solutions like mycelium? And we're going to start with foam for our footbeds for ultimately an underfoot mycelium alternative, which is super exciting. And this is set to be another huge step, no pun intended, towards our regenerative bare footwear goals, to perhaps make footwear from nature, to connect to nature, and ultimately return to nature.
Sorry, Asher, can I interrupt just for 1 second? I'm sure everyone's seeing Gavin's videos having issues. I think Gavin's going to step off for a minute to fix that.
Sure.
We can continue talking and then he'll jump back on.
Okay. Good luck, Gavin.
It wouldn't be a proper Zoom meeting if we didn't have some
technical issues. Yeah. And so, yeah, look, perhaps in Gavin's absence, and Gavin also touched on it, like mycelium is amazing stuff. It's, billions of years old. As I understand, it's like the first land-based life form, descendant from algae, which I think still forms the base of the kind of oceanic food chain. And what's really cool about it is that it's effectively like nature's nervous system, like woven into the forest floor, I think Gavin was saying. and it connects the roots and distant trees. And I think I read the other day that you know, scientists dub it the wood wide web, which I quite like, or nature's social network, and that's cool. But I think the connection to Vivo is our USP is really about sensory feedback. And the idea here is that your feet have exactly the same amount of nerve endings in as your hands. They're like the ultimate movement sensor. You know, they're made to feel, and kind of it connects, you know, our feet connect to the ground and to our brains, allowing us to kind of move efficiently and injury free, like we've been doing for millennia. You know, much like the kind of mycelium network in nature, our nervous system is our movement and sensory network. And so, you know, look, there's a lot of brilliant reasons why we're working together, and we're thrilled to be on this mushroom journey with Gavin and all the big intelligent people at Ecovative. Yeah.
And actually, I have looks like Gavin's back, but I have a few questions for you based on what you said. So did I hear you say that you're from a line of cobblers?
Yeah, I am, for my sins. I mean, look, you know, you could start at the beginning. You know, feet go back hundreds of thousands of years. Our great ancestors had the same ones we've all got today, and bodies and brains. Footwear goes back tens of thousands of years, and were originally kind of ultimately tools made to protect us from cuts and cold, but that's it. Yeah, it's been, you know, we've been wearing bare footwear for the majority of that time until humans invented shoes for riding horses, you know, with heels and pointy toes, which still seem to be largely the flavor of today. But yeah, I'm a Clark, so the Clarks Quaker cobblers go back 7 generations. And I think, yeah, 1825, my great-great-grandfather, Cyrus and James, had a little Quaker business that you may be aware of called Clark's, which, you know, at the time was, you could say, one of the kind of original B Corps of yesteryear, that was all about quality and innovation and community. And, yeah, I mean, you could say that, you know, making a business and ultimately footwear is a force for good is kind of in my genes or part of my mission. But yeah, today I think being a cobbler is about looking to nature for solutions. And yeah, we don't make shoes with fancy underfoot technology that interrupts natural movement. We think that the cobbler of today is maybe making footwear that puts feet and people and planetary health at the center. And in this case, I think making footwear from nature to be returned to nature is just a really exciting goal that we're on with Gavin and Ecovative.
Oh, wow. So you actually have expertise in this area and can talk really well about you were talking about the sensory component of the foams. So what do you think about it? I should have asked you this when Gavin was off. Could have gotten a more honest opinion.
Yeah, I mean, what do I think about it? I mean, I think it's yeah, it's just it's a kind of, now that the technology is available, it's a really kind of obvious first step, as it were, for us to trade out the petrochemical solutions in an item that is in our footwear that is made with less sustainable alternative. So yeah, it's a great first kind of component to kind of look at and focus on.
So we do have this question and I'm wondering as well, so when can we actually buy the shoes?
That is a great question. We're hoping it's a kind of sub-in kind of item, so we're hoping it's kind of not too far off, and yeah, it depends on the gates that we ultimately are going through now to go from prototype to testing and ultimately getting it production ready. So I can't give you an exact answer. I'm going to have to leave you a little bit hanging on that.
Yeah, I can certainly speak to in terms of where we're in a development process today and the critical importance of us working with an organization like Vivobarefoot. So when you think about the apparel industry, these types of garments, inclusive of footwear, are really composite materials. And so it brings together not only designers and brands, but there are a number of parties and stakeholders throughout the supply chain that are really important for us to engage with and to learn from. So these include to ensure that our products and materials can fit directly into the processes that the suppliers that Vivobarefoot, among others, use in order to create amazing footwear. And so today we've been sharing first generation materials to make sure that it integrates within those types of infrastructure, as well as garnering feedback that help inform the rapid development of these mycelium materials. And so later this year, we'll be sharing the most advanced mycelium materials in the world with Asher and his team to continue to integrate into some new footwear opportunities. And so we're in this iterative learning cycle today, and this has been very powerful for us to date.
Oh, wow. Thank you, Gavin. Actually, I have a question on that, but I wanted to stop for a second because we have some polls that we'd love to get everybody's opinion on. So if we could pause for a second, and then we're asking two polls, which you can access on the tab on the right hand of your screen. Two things. One, we're wondering, when your company is looking to implement biomaterials for the audience. If you're curious about these materials, you want to use them, when are you looking to implement them? And then the second question is, what do you think the most useful aspect of mycelium for the fashion industry is?
Okay. That's to me, I guess, the first one at least. I think...
No, sorry, Asher, those are for the audience. Those are polls for the audience. Yeah, so we're curious to get, there's a lot of people here, again, from all over the world who are also brands or other mycelium companies or other next-gen material companies. And we're curious to get some of their feedback. And then once we get those answers, I'll let everybody know what we see. But then back to actually, Gavin, what you were just talking about. You said before in your presentation that it's very easy to integrate your mycelium into the supply chain. And I know when we talk to a lot of brands, that is a concern with next-gen materials, that maybe they won't fit into the normal process. And I'd love to hear more about that because that's a very exciting, positive aspect for the industry.
Yeah, of course. And so as I mentioned in the presentation, we've been developing this family of mycelium materials for over a decade at this point. And over that time, we've had the opportunity to work with various forms of the current apparel supply chain to understand which processes are currently employed, from the adhesives and stitching technology that's used to the ways that they mold and form some of the plastic foams that are used today. And what this has allowed us to do is to first assess the core characteristics and properties of mycelium to understand how and what process conditions are required to fit them into some of the footwear categories specifically. So for example, today plastic foams tend to be molded using some forms of heat and compression. Those are same processes that are actually applicable to the mycelium strain that we developed for the forager foam technology specifically with that intention. And so there are certain temperature requirements, process cycle times that we can't change meaningfully without having an impact on how the product or finished good is created. And so those are learnings that have been really powerful for us in ensuring that these materials can integrate into some of these operations.
And actually, I had another question for you too, because I think what you said about being able to recycle or put the scraps back into the system makes so much sense. How much do you expect of the cutting and that type of processing to happen at your facility, and how much do you expect it to happen at the brand's facility?
So our focus as an organization is on the mycelium, and we're not a foam converter. We can do things like slice as an example, or do some processes for prototyping, but we're really not the best party to be producing a finished good like a piece of footwear as an example at scale. And so that's also why it's so important for us to be working with the tier 1 through 3 suppliers that any of these apparel brands may have in order to provide those materials and then understand those scrap rates. They will certainly not be meaningfully different than what the conventional plastic foam industry experiences. The key distinction is that at the end of the day, rather than having to put it into a recycling stream, if the materials are recycled at all, we can either reclaim those or put those into a plant-based compost system in which the materials will passively return to the earth in a period of just 12 weeks.
Oh. Actually, I think I did see at some other point you had something on the degradation of the materials. It really is amazing how quickly that happens.
Yeah, what's really important for us, and I'll make the distinction between biodegradability and compostability, because oftentimes plastics themselves are biodegradable, meaning that biology or life can break these materials into smaller particles. That, of course, has led to the things like the recognition of microplastics within our surrounding environment, making their way into other types of life cycles and things of that nature. For us, we focus on compostability. So that means that we take very seriously things like ecotoxicity, as well as not only producing compost from our products, but demonstrating that they can grow the next generation of plants, which of course are then the raw material that go back into our system. And so for compostability, it's important that it happens within a short cycle. And for our products today, they're certified for no longer than 12 weeks.
Well, and actually that brings me to the poll results, which is actually 75% of the participants today say that circularity is the most exciting aspect of materials. And that's exactly what you're talking about, is that ability to go back into the system or the ground without the toxicity. So at least you're speaking to the right audience. That's exciting that everyone here understands that. And then let's see. Oh, another exciting. So the second poll question, I'll give you a reminder, is when is your company looking to implement biomaterials? And 43.5% say yesterday. So I think everyone's very excited and wants these. I will say I hear that a lot from people in the industry. Innovation takes time, right? But did you say, Gavin, it's been 10 years that you've been working on this?
Yeah, that's right, for our pure mycelium foams. And so this technology was originally spurred from our mushroom packaging technology, in which we were starting to really garner more control over how the mycelium grows and how it performs after different types of growth environments. So as an example, fungi are what are known as modular organisms, which is similar to plants. So they respond to their surrounding environment. Plants, as an example, will grow to the light. Fungi have other environmental factors that dictate their growth. And so that initial exploration was what allowed us to go from a composite structure, like this little myco robot here, to growing something like pure mycelium, which has the elastomeric properties or resilience that's required from the footwear foam industry. And footwear foams are a very large market, and there's a huge family of materials, which Asher's better to speak to than I am, that currently serve those needs.
Yeah, actually, Asher, let's bring you in and talk more about what your experience has been in working with, this new innovation. And it sounds like you might have been seeing some of these materials throughout the process, giving Forager some feedback. What has that experience been like?
Yeah, I mean, I guess to take a bit of a back step, we're not new to kind of being, guinea pigs of bio-based materials or new natural materials, etc. And we had a go with some algae-based foams in 2017, and some bio kind of polymers with TPU and so on with some of our sneakers, and of course the whole world of natural-based performance materials is super exciting, of which Ecovative and the Mycelium kind of piece is clearly playing a big part in. So yeah, the initial kind of foams and so on, we've recently kind of got our hands on. Just to Gavin's point, it's a pretty straightforward. It appears to be a pretty straightforward switch into heat and compression, which you get with insoles and/or heat and compression that you get with molded parts or other areas you'd need foam, and of course it's kind of grown from nature and has a kind of very quick biodegradation story with low toxicity. So it's just, yeah, it's really thrilling to kind of be at the beginning of the journey on this, and we expect really positive things.
And do you have any feedback from your customers? Do you know what they're really looking for in new products and what they think about these next-gen materials?
Yeah, I mean, I think in general, I think customers want uncompromisingly good product that delivers on a kind of a people or performance level, and ultimately on a kind of planetary level. So, it kind of the materials thing, of course, is super important, but if the product, and in this case footwear, isn't amazing at the job, then it's effectively not fit for purpose. And then from a kind of materials point of view, it needs amazing sustainability credentials, and really important to have all the transparency, which of course is really challenging with complicated product like footwear being made in overseas supply chains. But these kind of lighthouse material kind of materials like the Mycelium foam is really kind of switches on and kind of engages the imagination of the customer. And I think that has a really important ripple effect business to business when you can create stuff where there is a customer need, and ultimately inspires businesses at large to make changes and to put more time, energy, and investment in these emerging technologies.
Well, I think you hit on a really important point, which is how critical performance is. That no matter how wonderful these materials are for the environment or animals, it's really they're not going to be successful if they don't meet the consumer's performance needs. And Gavin, I think I saw in your presentation some of the testing that you do on the materials. Can you talk a little bit more about the performance metrics that you're trying to meet, and how you ensure that the products do that?
Yeah, certainly. And so working with Vivobarefoot, they actually provided a suite of key or critical to performance metrics that the Mycelium needs to meet in order to ensure that it's delivering the right quality and expectations of performance to Vivobarefoot's end customer. And so that ranges from everything from the compression set and fatigue, so how many times can this material truly be stepped on and rebound, to things such as the resiliency and rebound or impact of the product. We also measure key critical characteristics around how the durometer, or how soft or stiff a material is, which really helps dictate things like comfort. In our development process, these types of metrics are really important because we can do high throughput testing, resulting in lots of different types of mycelium structures, which we can then image on the microscopic scale to understand how that matrix of mycelium fibers relates to those physical properties, and then do the physical testing itself. Then that allows us to create predictive models that then inform and ensure quality in our commercial production.
So actually, we have a question that actually makes me think about what you just said. So somebody had asked about the different fungal spores, and if you're able to share what you use and how that does impact the performance, because it sounds like maybe you might be testing some different ones out to ensure you're meeting those performance metrics.
Yeah, certainly. So first, we actually don't use spores. We use mycelium, which is the root-like structure of mushrooms, as I mentioned earlier. And what the important distinction is that one, spores can actually be human allergens, so we stay away from those. And two, the spore is a new genetic material. And so that could actually have an impact, negative impact on product quality. So we are starting with basically the same individual and taking cuttings day after day, week after week, of the exact same mycelium strain. That ensures that we have consistency and continuity within our product. Today at Ecovative and through Forager, we tap into what we call the Forager secret, which means that our team can go out into the woods and identify mushroom species that are growing along the forest floor or on the side of a tree that have some really interesting material properties. So as an example, the fungus that we use for Forager foams is one that grows on a tree. and is so tough and tenacious that I could hang my own body weight off of this individual mushroom that's really no more than a few inches in terms of total size. That was a really good leading indication that it would have the right performance and resilience characteristics that would be used for a foam like this. And so today our team goes out all around the world, identifying species that are right for the right environment in which the materials are grown and right for those performance attributes. And then we start to interrogate or tease out the right ways to cultivate the mycelium consistently to garner that type of performance. So today, our strain library has over 300 individuals, which are all wild type organisms that we sourced from the forest.
That sounds like an awesome job. Yeah, looking in the forest for new species. That sounds really incredible. Actually, so we have some really good questions here. So we have a 3D print designer in the audience, and they're wondering if there's a way to use mycelium in the 3D printing process in the near future.
Yeah, that's a really great question, and really do see even the growth of mycelium as, in essence, a additive manufacturing process, because it's in essence transforming agricultural residue into this structure of mycelium that grows above the raw material base. But from a traditional 3D printing scenario, today we actually have partners that are using what we call our grow-it-yourself kits, which is how we grow our mushroom packaging materials, and putting those into print heads to create really beautiful and intricate designs that can be used in everything from furniture to building construction applications. Today, we don't have anything that's available for the fashion or apparel industry, but that might be something that develops out of relationships like the ones we're working with Vivobarefoot.
Actually, Asha, I have a question for you. This comes from the audience, but I think it's an excellent question, which is there are quite a few mycelium companies currently, working on, varieties of different products. What advice can you offer to brands on selecting reputable producers that offer performance, circularity, capacity, etc.?
Well, look, yeah, my understanding is Ecovative are the original kind of mycelium material kind of makers, and I don't want to kind of get this wrong, but that one of the key, you could call them first movers in the kind of mycelium leather world, I think uses the Ecovative way, as it were. So look, for us, it's really simple. We always look to work with, to look for like-minded partners, and we really want to have long-term relationships, both in the value chain and with our kind of material partners. So, I mean, my advice is kind of think long-term, think systemic change, and you really got to think about the whole picture. You need a supply chain that is really willing to go above and beyond, and you need to work with people that, because it will take above and beyond kind of energy outside of business as usual to really make these things come to life and have impact. And then I guess finally I'd say, you can't be afraid to kind of test, learn, fail, repeat, and kind of move really fast. You're not, you're going to get things wrong, but I think the overall, the overarching impact of making this happen, because ultimately time's not on our side, is important to kind of garner that kind of nimble speed. I hope that answers your question.
Well, and I think too, I mean, because it sounds like we do have a lot of brands in the room, that these type of partnerships, we've heard from a number of material companies, are so useful. Like what you were saying, Gavin, is bringing the brands into that process so that they can experience and test the materials as it's being developed. That's a really big advantage for not only the material company to get that brand expertise, but also experience for brands to be a part of the process, know where that development is. So like we saw so many people want these products yesterday, right? That's what we're consistently hearing. But we do need the whole industry working on this together, that, we can't, I know we're impatient, right? And especially what we're seeing is happening in the world and these being amazing solutions. but we need to support the material companies in the development because we don't want to put subpar products on the market, right? We need the high performance as well as sustainability. Gavin, I'll actually give you an opportunity if you want to talk about what really makes you different.
Yeah, certainly. So there's a couple of key distinctions about Ecovative among other types of biomaterial companies, and particularly mycelium technology companies. As Asher mentioned, we're really the innovators and leaders in this field. Being around for 15 years, we've developed a lot of technology and have also scaled technology in other fields, which has given us the bumps and bruises we need in order to ensure that we do it right for this principal technology. And so what that includes is things like our Mycelium Foundry, which is a very unique toolkit for growing mycelium using solid state fermentation. So what does that mean? So today, if you think about beer or how pharmaceuticals and drugs are produced, they typically use liquid fermentation. So you're feeding a microbe, typically a yeast or a bacterium, a sugar in order to produce a target molecule. At Ecovative, we use solid state fermentation, which is the conversion of agricultural debris into things like mushrooms. So mushroom cultivation is solid state fermentation. And there's lots of infrastructure out there for liquid fermentation, but not a lot for solid state fermentation. So we've had to develop toolkits that allow us to rapidly progress research in a fashion that you would experience within liquid fermentation for our unique mycelium materials. The other key distinction is just scale. So one of the things that we've learned through our experience in mushroom packaging, among other products in the furniture industry that we've offered, is that there are lots of opportunities to adapt technology from other industries, and we shouldn't try to reinvent the wheel. And so one of the things that we've successfully done to date is we've been able to integrate into existing mushroom farm infrastructure, which is widely available worldwide, to grow our materials at scale. And that allows us to have vision for economic compatibility, as well as the ability to deliver the volumes that organizations like Vivobarefoot and beyond really require. And so those are real meaningful distinctions between us and other players out there.
Okay, I'm really overwhelmed with the amount of wonderful questions we're getting. So I'm going to have a couple more, but so we have about 12 more minutes before the networking session. But I also just want to make sure that people have a way to ask additional questions later. Is there a good way for the participants here to get in touch with both of your companies?
Oh, certainly. From our side, you can just reach out directly to hello@forager.com. And so that's something that can be reached pretty easily. Okay. I'm sorry, forager.bio. Not .com. So hello@forager.bio.
Yeah, and assuming there's not going to be many of you, you can reach directly out to me, honestly, to asher@vivobarefoot.com, or go through official comms channels via our website, vivobarefoot.com.
And I'll ask you that question again in about 10 to 12 minutes. But okay. I just want to make sure that people aren't, people do have that, because we really do have some wonderful questions. So I'm going to summarize a few. One, a synthetic biologist who's in the audience is wondering about genetic manipulation. So what do you see, Gavin, and how much do you see micromaterials evolving over the next 10 years from research in strain screening and post-growth mechanical chemical processing? And how much do you think that genetic engineering of fungal strains will play a part?
Yeah, certainly. So today at Ecovative, we actually have a 7-year track record of engineering fungal strains, filamentous fungal strains, which have, as your geneticist in the audience will know well, very unique considerations and challenges associated with that. And so we've had an opportunity to work with best-in-class universities from MIT to New York University to assist us in developing the right toolkits for engineering strains. We also use molecular biology just for understanding. And so as we're harvesting new materials, we can then unlock and decipher the genetic code to see what's being turned on or not being expressed in order to garner more control and understanding of our products. Now, when we engineer a product, that means that our tissue itself is the product and it's genetically engineered. So today we don't offer anything for commercial sale that has been engineered, because there are some considerations associated with that. But we do think that it has a lot of potential to garner next generation performance characteristics beyond what the wild type strain can do from nature.
Thank you. I'm learning so much here too. So I know we've been talking a lot about foam. I do have a question about leather. So someone is asking that, do you need to treat the leather material? So when the mycelium is raw and it goes into a product, does there need to be backing or coatings, or what would happen in that dye process?
Yeah, certainly. So for forager hides, which are designed to integrate directly into tanneries, again, another really critical component of supply chain partnerships, we focus on being an entirely plastic-free option, because we think that it is divergent from our mission to have to take a beautiful natural material and cover it in plastics. That's true for our foams as well for our leather-like textiles. And so all of the performance that I illustrated in that slide earlier, in terms of tensile strength, that's garnered entirely from the mycelium alone. So there's no backing required and no plastic coatings. With that said, there are things like abrasion characteristics for durability in certain types of applications, which may require a urethane coat, thin urethane coat, like what's used in leather-like materials today. But we've also been working with tanneries and tanning companies that predate the dawn of plastics, because leather's been around much longer than plastics have, and they've had the same challenges during that time. So by using plant-based resources, as well as other resources that are not plastic or petrol derived, we have been able to create products that are finished and beautiful without any need for the petrol economy.
Thank you. And then we do have a couple of questions around end of life. So I'll kind of summarize these together. How do you trigger the decomposition of the material, or does that happen naturally? And how long will the products made from the mycelium last?
Yeah, certainly. That's really important questions, because I'm sure Asher and his team would not want material to be decomposing in a footbed, in a shoe, as an example. That's not delivering value for anyone. What's really important for compostability is that it has to be exposed to the biota, the bacteria and fungi that live and reside within the soil. These organisms have the great toolkit and enzymatic diversity to break down the mycelium and passively return it to the earth. And so for compostability, be it in your plant-based compost pile in your backyard or within an industrial system, the material has to just be broken up into small fragments, increasing the total amount of surface area and giving it more of an opportunity for those soil microbes to digest and break down the mycelium itself. So from a durability perspective, which is a really important consideration, we have products that have served in durable applications like apparel in the past. These include things like rigid board insulation, which of course has the same type of high demands for performance and durability needs. And within a built environment, as an example, these materials will subsist for in excess of 30 years. And it really comes down to exposing them to the right environment for the right period of time.
Thank you. So we have a number of people interested in how to use these materials in different industries. So let me just ask a couple of them together. Can food be exposed to the mycelium? Can you use the mycelium in like packaging materials? It sounds like, a replacement for the pellets, the peanut pellets. And then someone else is wondering about bracing. So for orthopedic uses, they really only need small quantities, but they're wondering if you can, eventually we'll see people being able to buy off the shelf rolls of the mycelium foam.
Gotcha. Yeah, that's a really good list of questions. So the first one was related to food contact, if I'm not mistaken. So today, when we think about mushroom packaging, we use that principally as secondary packaging. So think about coolers that insulate and then provide the temperature conditions for food in transit, or things like wine. Today in the US and Europe, our products are not certified for direct food contact. And that's truly just because we haven't done that certification today. With that said, we also have a sister company, My Forest Foods, that actually grows food products out of gourmet and edible mushroom species to create alternatives for whole cut meat. So making alternatives for things like steak and bacon, as an example. So there is an opportunity to create food packaging and other materials that could even be edible at the end of their useful life. The second question, remind me, is about...
I think it's peanut pellets or packaging. Is it like...
yeah. So on the packaging side, we actually provide custom molded geometries as our sweet spot in the industry. So we don't do loose fill packaging. There's lots of really good examples of loose fill packaging that are out there today, from little paper pellets to things like cornstarch peanuts. But for us, we focus on custom molded geometries where you would find plastic foams that are used in everything from e-commerce goods for personal care items to furniture applications in large industrial goods, where we have great strength and we can be very cost competitive in custom molded designs. And then the final one was about, please remind me, Nicole.
Like braces with orthopedic uses.
Yeah, you know, what's interesting about that is we actually have a published paper. And so Asher put his email address out there. I'll put mine out there. I'm just simply gavin@ecovative.com. And you can drop me a note, because we did a line of research in this area in the early teens. And we do have a published paper that I can share with you on certain applications in bracing as well as uses in prosthetics. And I do think that this could be an interesting application long-term. And of course, today we're focused on delighting our partners like Vivo in the apparel industry.
What about furniture? Can this be used in furniture?
Yeah, very much so. So some of the largest volumes of plastic foams today are used in the cushioning for chairs, similar to the one that I'm sitting in today. And so that is an area of interest for us. And that requires substantially more volume to serve. And so that'll be something that will follow applications within footwear and other apparel for us. We have offered for a long period of time other types of structural components for furniture. And we have a few partners in Europe that actually grow furniture componentry for different brands.
So there's a lot of questions about when these products will be available on the market. So when people can buy them, and questions about it being available in Europe and Asia as well. What are your expectations for growth?
Yeah, certainly. So where I sit today, we operate the largest aerial mycelium farm in the world. And we're currently building one that is more than 10 times larger at this juncture. And we do look to start to integrate into some mushroom farms internationally as early as next year, as well as building some infrastructure for the European market. Today, we do have partners for mushroom packaging on 3 continents, including a number of parties that are between the United Kingdom, the Netherlands, and Italy that are already growing some amazing mycelium materials for different industries.
Okay, well, we only have about 2 minutes left. So I'd love to pass it over to both of you to see if you have any closing remarks or any advice you have for other, entrepreneurs, brands, scientists, investors looking to support companies like yours or the industry. Asher, I'll go to you first.
No, I guess I don't have much advice. I mean, I think at least from my perspective, a little bit of ignorance and a bit of grit kind of has got us to where we're at today. But yes, stay focused on what it is you want to do, and you might have to bet the farm on it, and and I think you can get some stuff done. Yes. So.
I think that is a great piece of advice. I think grit is really important. Grit and determination. I have 2 children. I tell them that all the time, waiting for the time when they will realize that. But I think that's a really great piece of advice. Thanks. Okay, Gavin, I'll pass it over to you.
Yeah, in terms of closing, I would encourage anyone who's interested to go check out our website at forager.bio, where we also have that full animation that Nicole was talking about earlier. And then later this year, we're actually going to be opening up opportunities to the broader community to have an opportunity to work with our forager foams and hides. So these include independent designers and students, where we will be sharing with a wide range of organizations and people these first generation materials in order to get their feedback and have the opportunity to integrate into their own designs. And so that will follow our efforts and activities with organizations like Vivobarefoot, but we really do think it's important to democratize these materials and get as much feedback in this early development as possible.
Great. Thank you so much. So let me make sure again, everybody has everybody's email. Oh, great. So Stephanie put those in there already. And then I will also add mine in case anyone does want to get in touch with me. Education.org. And thank you both so much for all of the insight you provided today. Really appreciate it. It sounds like the audience was really engaged. I'm so sorry to everyone whose questions we didn't get to, but it's really exciting to see how many people are very interested in these products in this new industry. So now we do have about 29 minutes left for networking, and I'll see if we've got, I'm so sorry, I forgot. We're going to send out a link for some feedback on the webinar. We always try and make sure that we're providing the right content for our audiences, and we'd love to hear more about what you thought about today and any other advice or requests you have for future programming. You can see that link in the chat. And then actually, I would love to encourage everyone to join us at the Material Innovation Conference. So you can find that on our website. It's taking place virtually on May 18th and 19th. You can hear from Gavin again and a lot of other players in the space. So I'm actually really excited about the interest we've gotten so far in that event. And I think it's going to be a really great 2 days of programming. And hopefully we can answer a lot of the questions that we didn't get to today. So we can now head over to networking. So to access the networking area, you'll see the networking icon on the left-hand side of your screen. And feel free to join us over there. Thank you so much, Asher and Gavin.